and then choose model. So we'll do File, New Model here to start our open population model. Oops, New Model. Boom. And here we're going to go. And we're going to call this open population. And I'm going to call it SK. You don't need that moniker to be set it. Okay. So the first thing we're going to do in this, that we actually should have done in the previous model if we were careful, would be to go to the models. Well, we're going to go set the time unit of this model to be a year. Ladies and gentlemen, how do I set the time unit of a model? Where do I go? To the model as a whole. And here I'm going to set the population to be years. Okay? Okay. I'd like now to go create an agent class, which is going to have a person shape, and I'd like to create a population of people for that population, which is going to be initially of size given by a parameter called population size. Okay. So tell me the steps I should do. What do I have to do? Okay. Add a new agent type called person. Good. Excellent. And we want to lend them an appearance. So where do I go? Okay, person, and go to palette, and we're going to give them a person shape. That's going to be defined down in the presentation area here, or sorry, the pictures area. Give them a person shape there. Okay. And I want to add them into a population. Okay. So where do I go to add a population of them? Go to main and drag in. What else do I have to do besides renaming it? I have to do one other thing here. Set it to be a population of agents here. And we're going to make the initial number of agents depend on a parameter. And we're going to call that parameter population size. And we're going to set that to be a parameter. So how do we go add a parameter to our model? Tell me. General. Good. Add in a parameter called population size. Good. Who needs help? TA, help. TA, stand ready. There's okay, so we added in population size. Okay, and we made the population have a population be a population of size, population size. People see that? Okay. Now, what sort of thing is population size? Is it a double? Is it a Boolean, a true and false thing? Is it a string? It's an integer. Good. Good. It's an integer. Okay. So that's good. So next, I'd like you to go and we're going to. Well, first of all, I'm going to ask, where would we need to, in order to run this model, we're going to run it from an experiment, and we didn't give a default value for population size. This default value, this is a very important point. It's easy to miss in any logic. The default values associated with parameters such as this one, those default values are not initial values. They're values that if you don't give it a value in the place where it's defined. For example, if you have a parameter in person and you don't give it a value in the population definition, or if you have a parameter in main, as we do here, and you don't give it a value in the experiment, it would use this default value. Okay, we'll just fill it in with that expression. So we could fill it in here if we wanted to, or we could just go to simulation and fill it in here. So we need a population of size 100, okay? It's going to be a small population for this one. Okay? Okay. Sure.
So there was a question, maybe you can just go over it again. When you put the population size in there,
yes.
Why did that show up in simulation?
Show up in simulation?
When you go into, because then you can set
Oh,
the value.
yeah. Okay, folks, this is a very important point. Thank you, Kurt, for bringing it. And this is worthy of a nugget. It's nuggetable, okay? So there was a question here. When we go add a population to main, parameter to main, why is it that suddenly in an experiment we see a slot from it? Why is it we see suddenly a sort of little edit box appear in the parameters for the experiment? The deal is, if we have a parameter, remember the parameters serve two functions. Function 1, they serve to encode some assumptions, but the function 2 is they serve to communicate those assumptions from the point where something is created to that object that has the parameter. Here are the parameters in main. Population size is a parameter in main. What thing is it in the model that creates main, that brings it into existence? It's the experiment. The experiment is what tells main what to assume to start it off. And so when you define a parameter in main, the value of that to assume for that parameter is set in the experiment. It's just as if when you add a parameter to person, the value to assume for that parameter is set by the population. If you have a parameter in person, you have to go to the population to set its initial values there for those initial population. If you have a parameter in main, you set the values for it from the experiment. Are people okay with that? Okay. A question? Or TA? Yeah. TAs are deploying. Okay? Okay, ladies and gentlemen, I'd like now to go to run this model. What are we going to see? Anyone? We've rehearsed this many times. We're building those muscles. What are we going to see? Yeah, 100 people arrayed in front of each other in a most uninspiring fashion. Okay, and they're in a population of size 100 to be sure. Okay, so ladies and gentlemen, tell me one way that we could lay these people out randomly. Go to the environment of main and lay them out. But I'm going to tell you a different way, and a way that will be important when adding people in dynamically to a population. It's a different approach, but it's one that works better when you add people in dynamically to a population. It's one that's a little bit more advanced, so I've held off telling you about it, but it is important with an open population. So ladies and gentlemen, if you go to the population itself in main, this is going to be new material. It's important material for crafting a new model with an open population. If you go to main and you go to the population within main, you'll notice up here at the top, it'll say initial location. And you'll notice it gives a little warning. It says these settings are only applied if the user-defined layout type is set in the environment for other agents, properties of the upper-level agent. But you can specify a certain location, X, Y, Z, for this individual. So we're going to choose that in the specified point, and we're going to actually give values to use for their X and Y locations. Okay, we're going to tell what formula by which to create their X and Y locations. This is very useful, ladies and gentlemen. If you want to set their X and Y locations, say based on their characteristics. Suppose you wanted people with a higher income to appear visually at a different place in the population. Or suppose you wanted people who are from a certain level of education to appear differently, or with different age. You could set this in the X, Y, Z locations here, okay? So, this is the X, Y, Z locations associated with the population here. I'd like to put in a formula here. And the formula here will be simple. It will be a value drawn uniformly from 0 to 500. Okay? That's a random number. It's a double precision value drawn between 0 and 500.
Okay.
Yes?
Why is it you can't create
should be able to get it. So I'll start typing uniform, and I stand corrected. TAs, could you take that down? Any logic bug? Take that down, and I think we have any logic bugs document on Google Docs. Could you take that down? We'll send it to the mothership. Okay, control space. There's no response there, and it's evident that autocomplete doesn't work in that area. It seems it's not properly set up to work there. Okay, ladies and gentlemen, I'd like you then to go and run this model. And you should see people scattered around the space, like that, much like that. Do you see that? People see that? Okay, who needs TA help? TA help here? TA help in the back there? Okay, another TA help in sector 2? Front? Others? Okay, question or TA help? Yes.
Could you have done the same thing by putting an in-person agent on startup to give it a random
Yes, you could.
location?
Yes, yeah, you could use it to set their X and Y location. This is a little bit more transparent in the sense that it's part of the properties rather than being part of the code. Okay, very good question. Okay, other questions? Okay. Okay, now, the reason, folks, is that if you do it this way, this is an important point. For those who are a little bit further along in AnyLogic, you may wonder why I'm doing this way. This is the difference between AnyLogic 6 and 7. It turns out if you do it with random layout and we add people into the population, they don't appear at a random location. In order for them to appear at a random location, you're going to need to do it this way of setting the XY locations through population. It doesn't work to do it with random as it did in AnyLogic 6. Okay, so that's a difference. Okay, so are people ready to move forward? Are people okay? Okay, back, Alex, by you. Right by you. It was drawn between 0 and 500. Associated with the population. So, ladies and gentlemen, we've done things we've done before, with the exception of this case of for the population. We set it so the people's initial location was given explicitly randomly. We didn't just say choose it randomly. We gave a formula, and this is important because this formula could be used. It could depend on someone's properties, someone's characteristics, which is valuable. You want to set them so that they appear with certain characteristics, they're at a certain location based on their characteristics. It's also useful. Yes?
What does that mean underneath initial location, what it says there? These settings are applied.
Oh, okay. So it's a good question, and people can watch so this is a nuggetable thing. Okay? So, here in the initial location, it says these settings are applied only if user-defined layout type. What that means is, Robin, that I filled these in now and they're working, but they're working precisely because in main, if I scroll down here, I have a user-defined layout type. If I changed it to be a different type, they wouldn't work. It would ignore those.
So were you saying before when you said the difference between 6 and 7 that if you have random there that it doesn't really work?
Yeah, if you have random here, it works for the regular population, but if we add people into the population, it won't lay them out randomly. It only lays the initial population out randomly, not population as they come into the model. Is that helpful? Yeah. Okay. It's a little glitch discovered live in one of my boot camps. Okay. So, ladies and gentlemen, this is what I did. People comfortable with this? Okay. So let's move on. So here's another challenge associated with this. Folks, I'd like to create a sex and give them an ethnicity as well. These are both categorical variables. How would I add those to the model? Okay, we add option list. Okay, How do we add an option list from the palette? Would it be in here? No, we can actually do it. Maybe there's some way, but up here you can right-click and add option list from this whole model menu. Okay, maybe this is a nugget, Kamalpreet. So add option list. I'm going to right-click on the model, and we're going to go add an option list for sex. We're going to add then another one for ethnicity. When we add sex, we could specify the choices, female, and then male, and then we could say finish. Notice I'm capitalizing it because it's denoting sort of the concept of sex there. Okay, and then I'd like to add another option list for ethnicity. Ethnicity, and the question is which country should we use for the? Perhaps we'll have Asian, and then we'll have a melange. Okay, Asian, African American, and then we'll have Maori. Okay, African American. We can't do it as dashed. Sorry, African American. And then let's do Maori. And then let's do First Nations. And then let's do Caucasian. Okay, Caucasian. Okay.
How do you edit it if you, like I press enter and it closes it? So if you want to edit the category?
Okay, that's a good question. Okay, let's go back and do that. So I'm ending that nugget, and let's see if we can go back and edit it. I think I can do this. Open. No. It looks like here we go. Double click on it, and then you can go change it. Okay, you can go change them. Notice it doesn't like a dash. You can't do a dash. It's contrary to sort of how Java what it allows for names. Okay.
Click on it again?
Sure. So double click on this, or you can just click. Just click on it, and then you can click on these and enter them. Okay. People okay with that? Oh, do you want me to go back? Oh, I'm sorry. Asian, African American, Maori, First Nations, and Caucasian. Okay, it's kind of a melange of the countries represented. Although Australia, I think, is underrepresented.
Oh yeah.
So do you want to? What's the HSI? Okay. Okay, ATSI. Okay, there we go. Okay, so we have a set of ethnicities, which are diverse in their geographic heritage. Okay, so ATSI. Okay? Okay, ladies and gentlemen, we're now going to go and we're going to start working to assign these to the initial population. So, ladies and gentlemen, if we want to set it so that each person in the population has an ethnicity and a sex, where would we go to do that? Go to person first, okay? And what do we do in person? If we want to lend them a sex and an ethnicity, add parameters. Okay, we're going to call it sex lowercase sex. And what sort of type will it be? Capital sex. Okay, we want to add an ethnicity. And what sort of parameter, what sort of type will it have? Ethnicity. Okay, now, folks, where will the particular values to assign for these be assigned for the initial population? They'll be assigned in Maine. Where in Maine? Population. The population. Okay, good. So let's go back and do that for the sex population. So let's go up to, for the sex of the population, let's go up to Maine, go to the population, and for sex, we're going to pick the sex randomly with equal likelihood. So do random from, and do you remember what I type? Sex.values. That's what I type. It's one of these randomly chosen with uniform probability. Sex.values. Okay? People okay with that? Now we're assigning the particular values for the initial population. Okay? Who needs help? Okay. 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 Who needs a little bit more time with that? Okay. Okay. So I'll put it up on the big screen. There we go. Build early, build often. Use your build functionality. Get it to check your model. Get it to tell you if it doesn't understand your model. The build basically says, do you understand my model? And if it says it does, it doesn't mean your model's correct. It just means your model is something that AnyLogic thinks it understands. Okay? Are people okay with this? Okay, help up in the front. Sector 3.
The parameters are capitalized or no?
Parameters are not capitalized. They made them lowercase sex, lowercase ethnicity, because they will represent a particular sex, a particular ethnicity that a person will have. Does that make sense? Okay. Okay. Ladies and gentlemen, the question that we have, okay, question in the front there? TA, help? Very good. This is, I much appreciate the service rendered by the TAs, and I'm sure I'm not alone in this regard. Okay, other people need help? The next person will get professor help. Okay? Okay. People ready to go forward? Okay, folks, we're going to do something we have not done before, but which is a very valuable feature of AnyLogic. We're going to introduce a custom distribution. Okay? A custom distribution. This is new to AnyLogic 7. Take note, those who are old AnyLogic hands. Okay? So here, we're going to introduce a custom distribution object. And you'll notice that over in the palette, in the general form, there's a custom distribution component. You note that this is the beginning of a nugget. So we're going to add a custom distribution object, which is going to allow us to pick different ethnicities with different likelihoods. We're going to specify probability distribution, probability mass function over different ethnicities from that option list called ethnicity with a capital E. So we have this option list, and we want to pick them with a certain probability. So in our main class, we're going to add a custom distribution, which is going to be called ethnic distribution. Okay. So what did I just do? From the general tab of the palette, I added a custom distribution called ethnic distribution. Okay. Now, you notice we have a variety of types of custom distributions that we can define. This is very effective. We can define these empirically grounded distributions that are continuous in nature, that are discrete in nature, or, and this is what's going to apply here, they choose between different options. Okay? So we're going to choose that options here. Okay? And you notice it lets us pick an options list. And we're going to say ethnicity. And now we can give the relative frequency. I believe it's obvious, it's automatically normalized to sum to 1, so that we could specify the relative frequency of different ethnicities in this population. And so, perhaps we're in a population where Asians form 10% of the population, African Americans, perhaps 20%, Maori, 15%, First Nations peoples, 25%, and then Caucasian, 10%, and Aboriginal peoples from Australia, 20%. Okay? Yeah, that's, so here we've specified the relative frequency of different groups within the population. Yes? I think it would normalize it automatically. I believe from observations that that's what it does. And I'm piecing that together from a couple things. I don't have, but you could look up to verify that, but I'm almost certain, 98% certain. It does. Okay, that's helpful. Okay, so folks, so I heard confirmation that it does. Okay? So here we have a set, an empirical distribution. Well, this is pseudo-empirical associated with these diverse ethnicities that might be represented in our population. So having defined that custom distribution, how could we use it, ladies and gentlemen? How could we use that custom distribution to good effect? Okay. Okay, so now we have this ethnic distribution, okay? And we can simply call ethnic distribution, and it will return a value drawn from ethnicity, okay? Yeah. So here, we've imposed a draw from the ethnic distribution to introduce ethnicity into this population. So obviously this is a fictitious distribution, but the point is we can draw values for model parameters from empirically defined distributions that might be a match to our population of interest. Okay? Are people comfortable with that idea? If so, may we run this? Okay, so let's build. And now, ladies and gentlemen, let us run. Okay, and let us drill down into the population. Here's a female Caucasian. Here's a male First Nations people. Here's a male Maori, female First Nations, male ATSI member. Okay. So, ladies and gentlemen, we now have a population which exhibits characteristics that can be drawn from distributions that may match your populations of interest. Okay, ladies and gentlemen, what I'd like to do now is to add one more element to this. One more element. An element of significance for certain types of research, okay? And that's going to be, within person, I'm going to add in a representation of a person's mother, okay? Okay? So we're going to have here, we're going to associate people with a certain other person who's their mother in the population. Ladies and gentlemen, how would I have something that refers to my mother? Well, I can add a parameter, and what type would that parameter? We'll call the parameter be mother, and what type will that parameter be? It'll be a person. It'll be a reference to a person. Okay? A reference to a person. Okay. So, ladies and gentlemen, initially, we're going to assume that we're not going to set this for those in the population, but instead we're going to set this for those who come into the population over time through childbirth. Okay? So we're going to leave this empty. We're not going to specify any particular mother, and we're going to leave it, as we say, null for those who are currently in the population. Okay. Okay, ladies and gentlemen, I'd like now to put in place a network by which people are connected. And I'd like it to have a connection range of 75. Okay? Where do I specify a network for this population that's imposed? How would I specify a distance-based network? Two people are connected if they're less than a certain distance apart. People? Okay, we'll go to main, and we scroll down, and it's the environment area of main, and I can specify a network type, and I could say I want it to be a distance-based network with a connection range of 75. That's good. And then what else do I have to do to make that network visible? At the person level, we have to go where? The connections, which is tricky because it's sort of upwards of this area. Go to the connections, and we have to scroll down here until we get to this point, draw a line connecting agent. Are people comfortable with that? Sure. So what did I do? What did I do here, folks? I went to main. I'm trying to add in a network. I do three things. Remember these steps. To add a network here, I can go down in the enclosing, the class here that encloses the population of interest. I can go down and I could tell what sort of network I want to impose and the parameters of that network, things like connection range. So I set it to be 75, and then I go to person, and I set a person's connections. In person's connections, I scroll down from the top, and I set it to draw a line between connecting agents here. Kurt, could you come over here? Draw a line between connecting agents. Are people comfortable with that? You can offer lunch for us on Thursday. The faculty club can't do it. Thanks. So we're going to do draw a line between agent to draw that network. That thing we do in main is we're setting up a network. We're saying we want a distance-based network with two people connected if they lie within 75 range. Here we're actually saying draw the network. Yes, come up, Reed. Okay, it's connecting and reconnecting. Okay, that's really interesting. You mean the university network? I thought you meant the network in the model. Okay. Okay, that's really helpful. Thank you very much. But that's blocking the nuggetization. Okay. Thanks for letting me know. Okay, go manual in Excel. Yeah, that'll be great. Okay, CamelPreed is very helpfully dividing up these lectures into small pieces, which you could then access. So rather than viewing the whole lecture, you could find exactly how did I add that option list, or exactly what did I do in order to impose a custom distribution, or what have you. So she's dividing up to nice little chunks that we call nuggets. Okay, so with great relief, I'm going to run this, and rather than seeing a blinking network, I see a network that's stable. Okay, question? Question?
Yeah, I did have a question. I
Yeah.
wanted to ask, I know we didn't touch on it last time, but on connection,
Yeah.
the draw behind agent versus draw on top of agent, what is that?
Okay, so what that's about is if you had agents that have larger shape, let's suppose a circle.
Yeah.
Imagine a large white circle.
Yeah.
Sometimes they're so large you can't see the connections between them because they're occluding it, they're hiding it. And so setting the network connections to draw, associated with a person to draw a line in front of the agent means that you'll still see the line between them. They won't occlude it. They won't be in front of it. The line will be in front of the agent. That's a worthy nugget. Okay. Okay, folks, do you see this sort of thing? Okay, who needs TA help? The TAs are deployed to the corner. Okay. So can we deploy to the far corner there? Kurt. Kurt is. Okay. So where are the other TAs? Okay. 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 The cavalry has come. Hey, guys, over here, in the corner. David needs help. Okay. Others. Okay. Do you see this? Do you see this sort of thing? Now, obviously, we know how to color people according to sex or ethnicity, and I'm not going to go into that. We've done that before, but we could do that readily. But our interest here lies in a different zone. We have here a static population. Ladies and gentlemen, I'd like to set it up so that we have immigration going on, so that we add people to the population. We're going where this group has never gone before, okay? We're adding people to the population over time. Now, ladies and gentlemen, riddle me this. Based on what I've told you already, based on what we've seen in some models, how would we set up the model to be doing something periodically? It'll do something at a certain average rate, or even set it up so that exactly at every year it does something, like report out data. What sort of construct do we use to do that? An event. We're going to add an event. And we've done that before, ladies and gentlemen, for some simple cases. We've done that for cases of a single event at a time. At the beginning time. But let's set it up here. Where would, ladies and gentlemen, riddle me this. Where would that event live? It would live in Maine. Right. It'll live in Maine, this event, and we're going to name it Immigration Event. I dragged it from the palette, from the general area of the palette, into the model, and it's called Immigration Event. Okay? Okay, the TAs are doing brisk business. Okay, can any of the TAs give me feedback? Do I need to go over something again?
Maybe this event, immigration event.
I just dragged it in. I haven't done anything with it yet.
I just observed two person that has ethnic distribution in the person, so there's somewhat of work.
Oh, so yeah, very good. Very, very good. Okay, thank you very much for capturing that. So, folks, we're assigning, so the characteristics of personhood are such that they have an ethnicity and a sex. But the actual assignment of values for those is done in the population, for the initial population is done associated with the population. And therefore, it's most natural if the custom distribution for ethnicity lives in Maine, lives in the place where the population is, rather than living within the person itself. Because it's not an aspect of, it's not a distribution inherent in personhood. It's a distribution associated with the population. It's associated with a particular context, and that's captured in Maine. So that custom distribution is best in Maine. And this brings up a more general point, which I want to emphasize. And I know you're probably doing this in general, but it's very, very important when you add things in that you secure clarity on, are you adding this to person or to Maine? Because it's very easy to add it into one when you meant the other. I've done it myself quite a few times, and it's worth just noting what currently is open before you drag something in, glancing and making sure you're adding it into the right one. Okay? So hopefully at a conceptual level and at a practical level, that will help you avoid common mistakes. Yes, George?
If you're going to do this later, just get past it. But did you say that there was a way to physically distribute people on the grid according to something like ethnicity?
Yes. So one of the virtues of setting X and Y locations in the population, one of the virtues, George, of using this here to set, this here to set X and Y locations is we could put on a formula that depends on the person's characteristics. So, for example, if someone based on ethnicity, based on their income, based on their age, based on other characteristics, we could lend them an X and Y location here. And that would make their layout depend on those locations. Kurt.
Can I just share the proof of a very, very interesting bug?
Yes.
Okay, so on the screen right now, is where you're specifying the initial location. Remember how before there was another situation where we had X, Y, and Z, or Z, or whatever. If we specify the Z, then it doesn't do anything. But here, if we specify the Z, and then put in a distance-based network, people might be farther away, but they'll look close, because when it displays it on the screen, they're side by side. But because we're also putting it in the Z distance, they'll look close, but the network will say, oh, no, you're greater than 75, and it won't connect.
Because they'll be far apart in the Z direction. But you're looking at it like this. Yeah.
So be careful. In this case, putting in something Z actually changes the behavior of the one.
Yeah.
Because of the distance-based network.
Because of the distance-based network. So don't put something in for Z. Leave it as 0 here. Thank you.
So you'll get sometimes you get weird bugs. You just got to, follow.
Yeah. So we're not using the three-dimensional features of any logic. Perhaps for bats, maybe that's an issue. I mean, if bats roost in a certain area above the ground and then come down, it's not a crazy idea. But here we're just using things in 2D. Okay. Okay. Great. So, folks, here we have an immigration event. We haven't done anything with it. What will this need to do? Can anyone tell me? What will we need to do in the immigration event? Add the people to the population. And this is the key step for adding to the population. Okay, ladies and gentlemen, if you have a population called population, you'll do this dot add underbar population. And then you can either specify the sex, ethnicity, and all the parameters for the person coming in, or you can just use the default values. Now, if your population was called pop, you would do add underbar pop. I'm going to do add underbar population, and I'm going to specify their sex. How would I specify a randomly drawn value from sex? Can someone say? From, good, sex.values. Good. Okay. For the ethnicity, suppose I want to draw it from our ethnic distribution. Ethnic distribution. Now, clearly, if you had immigration occurring from a zone with a different ethnic distribution, you could use a different ethnic distribution. You could have an ethnic distribution for immigrants that's distinct from those for the model as a whole. And there's no problem with doing that. I'm not going to do it in the interest of time. But, if our immigrants were only coming from Canada, we'd be unlikely to have, a preponderance of Maori included. And so we would have a different ethnic distribution coming in. Here we're just going to use the same ethnic distribution. And for the mother, we will also give a sort of no particular mother for this person because we don't know who the mother is for this immigrant. So we'll say null. It's no particular mother we know of. Okay?
So you don't need mother in there, no?
You use null for it, and that means it's no specific mother. There's no person associated with it for the mother. We're going to leave it, basically it's like leaving it blank.
And it knows that it's the other parameter.
Yeah, it knows it's the last parameter. You notice, this is very important, add population takes things, in general, these so-called functions in any logic, they take things in a particular order. So this one, for example, will take sex first, and then it will take ethnicity, then mother. So you have to give a value for sex, that's this, a value for ethnic distribution, that's that, and a value for mother, that's that. So it's going to draw a random value from all possible sexes and use that for the first parameter for population. It's going to draw one from the ethnic distribution, use that for the second parameter here, for ethnicity, and then null here. Okay? Okay, question or TA? Yeah. TA? Yeah, sure.
Isn't this redundant here, and also do sex, ethnicity, and mother have to be in the same order as you define them?
Yes, they have to be in the same order. It tells us the order that it wants. So it says here you have to provide them in this order, and it actually specifies again what order. And is this redundant? No, it isn't. If we did it without these, it would use the default values as specified by the defaults for each of those parameters. And so when you define a parameter, you can specify a default expression, and it would use that instead. But we didn't specify for that for all the parameters. Oh, it's the this. Oh, I thought you meant this general. I thought you meant this in terms of the whole thing. Oh, no, yeah, you don't have to do that. It's just, I like to make it clear what we're referring to. So, yes, you don't actually have to do this. In Java, it's implied. Yeah. Okay? Okay, ladies and gentlemen, the final thing we have to do, we want this event, this is very important, we want this event to be occurring not on a single time, but over time with a certain rate. A certain rate, okay? And we're going to be setting this rate to be, and this is very important, we're going to set this rate. This is a neat feature of AnyLogic 7. Those who are AnyLogic 6 hands, pay attention to this because this is one of the neater features. We're going to specify the number of people, the rate at which people come in, how many people on average per year, our time unit. We're going to specify it using a formula. It's actually going to be independent of the time unit. So it's going to be 10 people per month. See this per month? So it's 10 per 1 month, okay? We can specify it, in other words, in a way that allows us to make use of sort of other time units flexibly. So here we have 10 per 1 month coming in, okay? And it will know what time unit our model is in and use it appropriately. Our model can be measured in minutes, and this would still work. Our model could be measured in time, and our model could be measured in months, it would still work. It can be measured in years, it would still work. So you say 10 per month is the rate at which they come in. Okay? People okay with that? Okay. Should we build?
Just on that.
Yeah.
In AnyLogic, a year is 365 days. A month is 30 days.
So actually, the situation is a little bit more complex than that.
Yeah.
I mean, it is convenient that we can specify this in this sort of way, and in our natural time units. So we could say 10 per second, right? What's more significant is that, with respect to your question, in the model, you can actually set it to actually use a real calendar. I'm going to have to go, see, you can set it to use a calendar where it actually takes into account weekends, weekdays, leap years, etc. And so it's actually more subtle than just, always 365 within a year. Is that helpful? Yeah. Okay. Now, exactly how that all unpacks for that, I'm not 100% sure, but I'm not quite sure. But I can use a calendar and go forward calendar by calendar. Yeah. Okay, ladies and gentlemen, let's build and let's run. Okay? So here we have people coming in. They're coming in with quite some rate. Okay? So they're coming into our population, but what's not happening as they're coming in? They're not making connections. So we have to undergo one specific step. So TA, over here. TA, here as well. Okay. So, okay. Where's Winchell? Okay. Are you helping someone? Okay. Okay.
Yeah, when I run, right? When I just run, they're not really.
Oh, okay. So that's interesting. Can I? Oh, okay. So it's with a rate. Yeah, that should be working. That's really interesting. Let's see if are they not being displayed? No, it's coming like that. Okay. So it's running. Oh, okay. I know what it is. It's the time unit of the model is given in minutes, and it's got to be in years.
Okay.
And then, because it was going by minute rather than year by year. There you go. Okay, folks, if the time unit of your model is off, you will, like if the time unit model is in seconds, it'll take a long time to see the first person appear. Often, unless you're running as fast as it can go. No? Okay, who needs help here? Who needs help? Okay, so we have a packed population, but they're not being added into the network. Okay? Okay, are people in sync now? Okay, so ladies and gentlemen, we're going to go through and knit them into the network. Okay? Okay, let's knit them into the network. So, ladies and gentlemen, when we have this immigration event coming in, we're going to need to tell it, hey, go recalculate the network. Okay? Go tell it, recalculate the network. Okay?
Why do we have to do that?
Because by default, it's not going to know to wire them in. And it's an unfortunate thing. They're not connected in. So as they're being added, they're not woven into the network. Instead, they're just coming in this disconnected fashion. See that? They're not connected with each other. They're not connected with others. Okay, so ladies and gentlemen, we're going to go to the immigration event. We're going to add one more line in this handler, one more line in this code that handles this. Okay? Are you ready for the code? Okay. This dot apply network. That's all you have to do. That's the line you have to add. I'll put it up on the big screen. There you go. You have to apply the network. Are people okay with that? Year. The time unit of the model is year. If your model is exhibiting dysfunction, check the time unit. Okay? Okay.
So as a general rule then, when you set up a network,
yes,
everything you're setting up that applies to that point.
That population.
If the population changes, you then got to put some rules in.
Indeed.
Right.
Indeed. And it gets messy if you apply a random network because it will shuffle it again. It pays no attention to what was there before. It configures out a new random network involving everyone instead of, it doesn't treat the new person as just asking to whom are they connected. It figures it, it recomputes the entire network from scratch.
So that's why you don't use apply random layout like you just did to the network here.
It's going to go all around. You got it, Cheryl. And it would have been especially obvious if you had made people different colors, for example. They would see suddenly the shuffling. Okay, ladies and gentlemen, are we okay with that?
So do you have a colon after each one of those big statements?
Yeah. There's a semicolon after each one because each of them is a command saying, do this one, do this top one, and then do this next one. And so after each of the commands, it's almost like an exclamation point in English saying, do this, do that. And, it's completing the sentence. It's indicating a kind of complete command. It's imperative, saying, add this person to the population. Apply the network. Does that make sense?
Maybe the reason why the computer keeps bugging out on this is we're all yelling at it. We have a question in the middle.
Okay, question. No. Okay.
So, also, it was the little light bulb suggests that we use self instead of this, so that's.
Oh, yes. Okay. Yeah. Well, I'll be. Oh, okay. I see. I see. Yeah, this is actually what self refers to here is the event. It's the event itself, and so you can say like reset me to fire again at a later time, or change something about my situation, suspend me. So self refers to the event. This refers to main. Yeah. That is confusing. Thank you. Maybe we could take that in the list of any logic suggestions. Okay. Now, yes, any logic is actually somewhat accommodating as far as missing semicolons, but sometimes it isn't. And I just think as a general rule, it's good to teach people, don't use semicolons when it's just computing a value. Do use them regularly when it's a command, it's a statement, and you won't get in trouble. Okay, so it's easier. They say that one of the most adverse situations psychologically that animals and people can be in is when they're periodically zapped. They don't know the situation that's causing it. It just kind of seems like out of the blue, and they can't control it in any way. And I don't like to have people in that situation where sometimes it's omitted and sometimes they have to put in, sometimes they don't. Just put it in as a general rule and you'll be fine. Yeah. The top one certainly wouldn't. The bottom one, it's somewhat. What it does secretly is it inserts a final semicolon after the last one. If you go look at the code, it's got a secret semicolon, but sometimes they don't. So it's better to just be careful. But yes, absolutely, as Dale says, within this code block, you have to have it here in any case. So you might as well just complete the thought. Okay, good. So, ladies and gentlemen, if we run this, we should see this network being built up over time. Do you see that? Okay. Ladies and gentlemen, I'd like you to note this pattern, because we're going to come back to this pattern. We're going to reflect on this pattern. The pattern is perhaps uninspiring at the moment, but just phenomenologically note its character, okay? Watch this. Okay, here are people coming in. We're going to next have people coming in through births. Okay? Are people okay with that? Okay. Ladies and gentlemen, we're now actually going to go and we'll disable this immigration event. It's useful to know how to do this in any logic. You can tell it to ignore this event, and notice it will gray it out. And that means basically pretend like it's not there. We can actually disable portions of our model through this ignore, and it will sort of temporarily just ignore it. Okay? So if you have something that's not quite ready, you want to show your model to someone, you're adding features in, you can ignore those new features and it'll be kind of nice. Okay? You could still show the rest. Okay. Ladies and gentlemen, we're going to ignore that immigration for now, but we're going to do something more significant. We're going to go and add in a representation of birth. Okay? So we're going to go down here to person. Okay? And we're going to we're going to go and we're going to introduce so in preparation for this, let's go to main first. We're going to add into main 2 parameters of significance. One is going to be a mortality rate, and one is going to be a birth rate. Now, I'm adding them to main rather than person for a couple of reasons. They're not going to vary between people. They're going to be easy to set because they're in main. We'll be able to set them from the experiment. And because it'll be less cumbersome when it comes to sort of adding people into the population. For all these reasons, I'm going to put these in main. It's arguable philosophically whether they should be in main, but because they have to do with person-related things. But as a pragmatic matter, many people using any logic, including myself, will often put these sort of things in main. So we're going to have a birth rate and a mortality rate. Okay? Actually, excuse me. I'm going to make it not a birth rate. It's going to be a fertility rate.
Okay.
Yes.
So, but if you did a mortality rate, wouldn't that be more like an age of death in a person?
It's
the rate is sort of.
So it'll be a mortality rate like 2% per year if the population sort of dies. So there'll be a 2% per year chance the person. We could, in general, we could have a mortality rate that depends on their age, and I've given you models where you can see that. There's a model involving smoking and heart disease where we have age-specific rates, I think, for mortality, a hazard rate for mortality. But here, for simplicity, I'm just going to have this mortality rate that every year they live, there's a certain chance. And just bear in mind, we can make it age-specific, okay, based on their current age. Okay? Okay, are people comfortable with this? So now, having done this, we've added mortality rate, fertility rate. Now let's go down to person. Okay? Okay. Ladies and gentlemen, I'd like now to add a state chart where people can be in one of 2 states. This is going to relate to childbearing specifically. They can either be in a non-pregnant state or a pregnant state. And after coming to term in a pregnant state, there's going to be a baby delivered. Okay, so tell me how I add a state chart like that. Okay, go add a state chart, and this will be called fertility state chart. Okay, great. And we're going to add in a state that's going to be non-pregnant, and another one that will be pregnant. Maybe medically it'll be non-gravid and pregnant or something like that. Okay. There's going to be a transition here. And it's going to be a transition from non-pregnant to pregnant and a transition back. Okay? Okay. So, ladies and gentlemen, this is going to serve as a reminder. In a fuguish sort of way, it's going to rehearse our experience with state charts and lend, hopefully, a new appreciation for their power. Okay, so tell me, ladies and gentlemen, for this transition from non-pregnant to pregnant, I'm going to call it becoming pregnant. I'm going to show the name, and we're going to set it so that we want it to go off at a certain fertility rate. So it's the rate given by a fertility rate per year chance of becoming pregnant. What sort of transition would that be? Would it be a timeout? Would it be an agent arrival transition? Would it be a message transition? It would be a rate transition, a chance per unit time. We saw that yesterday with interacting state charts, a rate transition. And it's going to be called becoming pregnant. Okay, but some people may ask, isn't there an important omission for the model? After all, fertility rates are calculated per woman in the population. Isn't there an important consideration being lost here? What is that consideration? Yeah, it should be only women that go. And this is I'm going to introduce a new twist with state charts. There's this thing called guard here, and that imposes a condition. In order for this transition to fire, this condition has to be true. And ladies and gentlemen, the condition here is going to be that sex equals what? Yeah, sex dot female. Okay? That's going to be the condition that it's going to check. Okay? Look at that. Sex. Oh, look at that. What a mistake I made. Rookie mistake. Do you see what happened? Look at that. It shows me a problems window. Cannot convert sex to Boolean. What mistake did I make here? We need double equals, not just single equals. This is an expression. This is saying, is it true or not? We're not assigning to sex. We're testing, is it equal to sex dot female? And so you need double equals. Okay? And it's going to occur with a rate given, okay? And now there's going to be a woven in additional strand here. It's going to be a rate given by what? Okay, fertility rate. And I could type that, but it's not going to be a happy camper. If I try to build this model, it's going to be unhappy. It says cannot be resolved to variable. Why is that? Because where does fertility rate live? It lives in Maine, ladies and gentlemen. So we need to say the fertility rate in Maine. Maine dot fertility rate. What is that Maine thing? This is a new AnyLogic 7 thing, and it lives up here. Okay? It lives up at the top. Try never to delete it, because weird things have happened. Okay. So here, now in old AnyLogic 6 and AnyLogic 5 terms, this would be get under bar main. Some people may remember it. I think I think all of us who've had experience with AnyLogic have used it many a time. But here we should say, and really, to be consistent with my notations, I like to say this. It's sort of the main associated with me is fertility rate. But you don't have to say that, okay? It just makes it clear who's sort of the basic person being acquired. Okay, so here only women can become pregnant. And what's going to happen? What event is going to transpire when they go from a non-pregnant to a pregnant to a non-pregnant state? It's going to be a birth. Well, no, it's going to be a birth in this case, and it's going to be a timeout, ladies and gentlemen, of what? 9 months. 0.75, or we could just say 9 times month as the timeout. Okay, 9 months. Or we could say 270 days or what have you, 270 times day, if you wanted to do that. Okay? Okay, ladies and gentlemen. Now, what is the action going to be? This is a key thing now. What is the action going to be? Okay, so who are we going to have to ask to add it? Okay, good. So I like saying this dot main, for myself, get my main, and then ask it to add population. Good, we're up to a roll. And what is the sex of the baby going to be? Okay, random from, and the set of all, tell me how I list out all the things that are possible in sex dot values. Okay, that's good. Okay, next, for the add population, it's going to have us list the ethnicity. So what ethnicity is this baby going to be? We'll make it the same as the ethnicity of the mother. So this dot ethnicity, my current ethnicity. You could just say ethnicity, that would also be my ethnicity, the ethnicity of the mother, okay? And who's the mother of the baby going to be? This. It's going to be me. This is me. I'm asking, it's the mother giving birth. It's the mother who's going from here to here. And so she's giving birth. It's her ethnicity. It's herself who's the mother. And we're going to add that baby in to the population. Does that make sense? Oh, sorry. Okay, let me put this. You're saying we need to show the whole thing, the whole kahuna. Well, sorry, the whole shebang. Okay. Okay, there we go. Okay.
So you don't have a mother?
This is, I am the mother. Well, that sounds strange. Sorry. If I were this person who's giving birth, I'm going to be the mother. And then it's my ethnicity that the baby carries, and then it's a random sex. Does that make sense to people? Does that make sense? Okay? Is that okay? Okay. Okay. Ladies and gentlemen, are we okay with that? So be careful of the balancing of the parentheses. So this parenthesis balance with this one with this one, and this one down here with this one up here. Okay? Question in the back. Yes, Kushik. No, because it's a good question logically. But only women are going to be able to get to the pregnant state, and therefore, because everyone starts in the non-pregnant state, and so I don't think we're going to need a guard here. If there's a male, what we could do is we could put in an assertion that checks, make sure that this is a female, because if it's not, all things are whacked out about the model, and it should warn us. So we could do assert sex equals this dot sex equals sex dot female. If you wanted to, yeah, it's not a bad idea. Okay, ladies and gentlemen, are we comfortable with that? Okay, ladies and gentlemen, are we ready to compute? Okay, so shall we go add this in? Right? Okay, let's go run this, and we're not seeing any births occur. Mortality rate and fertility rate is 0. We didn't specify values for fertility rate and mortality rate. Let's make the mortality rate and the fertility rate say the same. Let's say mortality rate of 0.15 and fertility rate of 0.02. Those are associated with the experiment. They're parameters for the whole model. Thank you, David. Okay, mortality rate 0.15, fertility rate 0.02 in the experiment, because it's the experiment that specifies the values of parameters. 0.015, yeah, sorry, and fertility rate 0.02. Okay? Yeah. Okay? So now we should see people being added in. Who are those people being added? Okay, those are newborns. Okay, folks, we're just about set. But those newborns are being added in a most unnatural place. They're all on their own. So let's add them so they're near the mother. Right? Wouldn't that be kind of nice? Okay. Okay. Okay, so folks, first of all, we're going to have a reference. We added this person, but who is that person? We don't have a way of referring to it. So, ladies and gentlemen, you'll notice that the way this is defined, this is very useful. This add population is defined. It actually returns a person. It returns the person being, if you go look at its definition, it returns the person being added to the population here. Returns the new embedded object. Now, that's the most uncomfortable reference, but it's returning a reference to the baby. It's returning the new person. So you could say, it's a person. This new person this new baby is a person. Baby equals this. It's the baby that's being added, and then we're going to set the baby to be appearing at a certain position. Sorry, I'm trying to get back to the thing here. Okay. So, ladies and gentlemen, we have, say, person baby. We're going to give a nice convenience name to the population member who's been created. And now we can set their properties. And the most important property we're going to set is their location. So here, baby dot set xy, and we're going to set its location to be very close to the mother. Ladies and gentlemen, how do we do that? What's the mother's location? Well, we can get it through, if we want to get their x location, we can get it through getX. But then we're going to perturb it. We're going to offset it by a certain value. We'll draw it from a normal distribution, say, with a, now for the statisticians in the room, those from strong statistics background, what I'm going to tell you may make you cringe. It certainly makes me cringe. Makes me wince. Okay. The normal, when you call normal, it draws samples of value from the normal distribution. All fair enough. You can specify the mean, mu, and a standard deviation, sigma. Fair enough. That's great. But guess what? You have to specify sigma before mu. So when you give it its parameters, first you specify sigma. So we're going to have a standard deviation of 10 and a mean of 0. I don't know about you, but it kind of gives me the heebie-jeebies. And here we go. And we're going to do a similar thing for the y position. So what are we doing? We're setting the baby's x and y location to the corresponding location to the mother plus a value drawn from a normal distribution, a normally distributed offset from that. And we're using this one here, normal, where you have a sigma and a mean, okay, mu. So this is what we're doing. And I'll go put this up on the big screen. So setting the baby's location to be close to the mom. Here we go. This is what we're doing. So this set xy, the first element we're passing it, this first element, so set xy needs two pieces of information to do its job. The first piece of information it needs is the x location, and that's going to be given by this guy here. This dot getX plus normal, this normal perturbation. It's going to draw from a normal distribution with a standard deviation of 10 spatial units and a mean of 0. For the y location, set xy also needs a y, and we're going to give it the mum's y plus a perturbation to it of standard deviation 10, normally distributed. Are people comfortable with that? People okay with that? Okay. Okay, ladies and gentlemen, if you've put that in, build early, build often. Okay, who needs TA help? TAs? TAs stand ready at the back of the room. Vigilant. Okay, nobody? Wow, okay. Thanks, you can stand down. Yeah.
I have a question. Is it possible to put like twins?
Put twins in. Yeah. So with a certain probability, they'll be twins. Sure. Do you, or maybe like maybe always twins, or like with the probabilities certain twins.
I would say always.
Always twins. Sure. What you could have is baby 1 and then baby 2. So what you could do is you could do this, or you could loop. So not everyone has to do this. I'm just going to demonstrate. So one way you could do is for I equals 0, I less than, and you could be 2, or if you're thinking about a litter of pups, it could be 5. And you could do exactly this. This would be a litter of five puppies being added. Is that okay?
Yeah,
So you do 4, I equals 0, I less than 5, I plus plus. This is saying, start this loop, I is 0, and it's going to go, and it's going to do this thing with I equals 0. It's going to do it that time, and then it will do it again. It'll make I 1 bigger, make it 1, and it will do it again, and it'll check if it's less than 5. Yep, it still is, so we'll do this again. Then it'll make I 2, and it'll check, is it less than 5? Yeah, it still is, so it'll do it again. And it'll do it for I equals 3 and I equals 4, and then when it makes I 5 at the end, it will check this. Nope, it's not, and so it'll be done. So this is the way to make it do it 5 times. Is that helpful? Okay, sure. So there's the baby is going to be, maybe it'll be called pup, but you could still call it baby if you wanted to. So does that make sense? Or we could have an if statement with a certain probability you have twins, okay? Okay, ladies and gentlemen, so here's a birth. Should we run it? Do you want to run it? Okay, let's run it. Okay, folks, here come the babies. Here come the babies. Do you see them? Okay, but there's one thing still missing. What's missing? Their connections. Ladies and gentlemen, you tell me now. Build those muscles. Look at those families being formed. Okay, you tell me now. Ladies and gentlemen, how would I apply a network? How would I achieve a network weaving them in? Okay, it's actually easier than that. How did we make that network knit the immigrants in before? We used a certain thing called apply network. We did it with an event before because we needed immigrants coming in that were, we sort of posited they came in a certain rate regardless of the size of the population. Here, we don't need an event to trigger this. We can just say apply network. This dot apply network. Just tell main, go apply your network. Is the person, and they're getting our main. We could also just say main.apply network if you want to. Nope, this is the mom. Still, the baby was named baby. This is still referring to the mom. This is the mom here. This is the mom. I'm sorry? The mom is already in the network. We're just telling main to knit. Okay. I see 2 different ways. Yeah, we could do it a different way, but this is the way basically telling main, hey, go figure, go recalculate what the network is, and because it's close to the mom, they'd automatically be woven in. But I like the idea of what I'm saying. Let's just directly attach the baby to the mom. Why have it do the whole network? Let's just tell it, attach the baby to mom. So here we go, ready? This dot connect to baby. Okay.
The way that you were saying, if there's a baby born next to mom that's somebody else's, it could get attached to
Yeah, if it was halfway between the mother and somebody else, it would get attached to both. Okay. So then they'd be attached to based on the general features we already had in the model, which might not be a bad thing. Yeah. But this is only attaching the baby and mom. Right. That's what I was thinking. I thought that seemed more natural because then it would attach it to siblings and stuff like that. So it seemed a more natural fit rather than just attaching it. Let's do it this way, and then we'll do it with the apply network, and we'll see the difference. Okay?
Can't you do both? You connect the baby, then you recreate the network. They'll already be connected.
Yeah, we could do that. This guarantees they're connected. The other one. Can you
have both?
Yeah, you could. Yeah. Yeah, I think automatically the babies could be close enough to the mom, almost with certainty that it will be connected by apply network. But let's just run this, and then we'll do it the apply network way, okay? Because I kind of like of connecting them up with siblings, so we'd have family structures. Okay, run here, and here we go, and here they're being added in, and you note they're being attached to their mother. There's all these kind of dyadic connections. Whoa, look at that. Do you see a difference from the immigration case? It's much more bunched, right? Much more bunched. These are families, folks. These are clans. Okay. Great. Now let's go back to that again, and let's do weave them into the network. So this .main.apply network, and we'll here just apply the whole network. So if the baby's close to other siblings, it'll be woven into them. It will be woven into other people close to the mother, and so we'll do apply network. Okay, this .main.apply network. In other words, it's my main. Oh, sorry. Here's person, and it's my main. It's the main associated with sort of my reference to main. So hey, here's myself. I'm going to get that thing called main. That's going to point to main, and it gives me a reference to the main class, and then I say apply network to that. Boom, done. Okay, and we're going to run it, and here we go. And now we're going to see these babies knit into the network. Look at that. Here they come. And we see these dense family networks forming. You see that? Okay, so ladies and gentlemen, our model is almost complete, but there's one important vital process that we have left out. Yeah. Okay. So here we go. So we're going to add it so there's mortality too. So let's add in mortality. Mortality is going to apply to people whatever state they're in. We're going to add a final state here. I'm helping you learn more about these things, about the different features of state charts. And this state is going to be called death. Okay. Sorry? Sorry, I just dragged it from the state chart. I should have emphasized this. I dragged it from the palette in the state chart side. I dragged it over to main. To person. It's a final state. It's this sort of thing that looks like a Libet. Sorry? No, I'm going to connect it up here. Okay? We're gonna put a transition from the pregnant state and from the non-pregnant. So from both non-pregnant and from pregnant state, we're going to have a transition here that will be going to this state. And from the non-pregnant state, this is going to be set. I want there to be a mortality rate. You tell me, what should I set these transitions to be? What sort of transition? Should it be a timeout, or they should be something else? It's a rate transition given by, okay, but if I just type mortality rate, what's going to happen? It's going to say it doesn't know where it is. It needs to be in main. Good. So I could say main.mortality rate. I'd like to be a bit pedantic and say this.main to emphasize it's my main, and really to make it very clear I'm referring to myself. Okay, this mortality rate, and I'm going to give it a name. I'm going to give it death of non-pregnant. Okay, so it's a rate, and this other transition is going to be death of pregnant, and it's going to be given by a rate as well, and that's going to be given by a rate of mortality rate. Okay, now we're almost done, but what's the final, how did I say, kicker? What's the final component that's missing? We have to remove people from the population, and we'll do that when they enter this final state. There's going to be an action undertaken, and that action is going to tell them remove from the population. Where does the population live, ladies and gentlemen? It lives in main. So we can say this.main.remove underbar population, and then we have to tell it who to remove. And ladies and gentlemen, who should we remove? This. Man, you folks are good. That's good. You folks have been doing a lot of Java snippets, and I admire your tolerance. I admire your tolerance. no tomatoes or anything. No, I'm really impressed. I'm really impressed. That you're finding this acceptable. Okay. Okay. So we removed the population. Should we run this? Ladies and gentlemen, do you want me to put that up on the big screen? Okay. There we go.
The rate is the same for the non-pregnant and pregnant, right?
That's right. No, men can be non-pregnant. Only women can go to the pregnant state, but men can be non-pregnant. Yeah. Yes. Oh, yeah, we could do that. That's a good point. So Bahare just pointed out, it's a very good point, that if we wanted to capture age in here, and we'll show how to do that here in just a second. We could actually capture it so there'd be a guard to become pregnant that is based both on age and on sex considerations. So you have to be between a certain age, for example. Okay? Yeah.
So why would you do it this way, like adding a final state to the state chart versus, say, adding in another event, mortality?
Okay, that's a very good question. I could see reasons for doing it either way. Visually, having that shown as this kind of final state, it connotes visually that that's kind of an entrapping state. That's a state to which people go; they don't come out of it, and so it might be a little bit helpful to communicate visually that this is a final exit from the model. But you could do it perfectly well with an event within person, or you could even it'd be more natural to do it as an event in person or in this way. Those would both be acceptable ways. And you could have an event in person. It's a rate event. It would go off according to a mortality rate. So I'll get to first. Yes, Chris. You could use the state, but yeah, you could use the state. It's just that, again, visually, that final event connotes finality. That it's not going anywhere else. Yeah, it's a sync event. It's sort of you go there and then you don't leave. It can also be shared between multiple state charts. So if you have multiple state charts sharing that same event, so it connotes this sort of they all can go there. So you can go there from a heart disease state chart, a diabetes state chart. It's a final, yes. Exactly. Yes, Alan.
That brings up a really good point, I think. In any logic, because you can do things so many ways, it's sort of hard to look at a program and know what it is.
It can be, right, because there's no one enforced way of doing with it. And what I would say is, if you have a choice between doing it multiple ways, in my group, I'd like to put the emphasis on making it transparent, making it visually obvious, because you will find example models in the AnyLogic example set where there's code hidden away which does something. And an example would be what we did at time 0, sending someone a message, having an initial infection. You can put that in an event, or you can put it in the startup code. But the startup code is harder to find. And so making it explicit, making it visual so you can go and making it labeled, that's a helpful thing. And so I like to try to err on the side of doing it a certain way. But you're right, it can be difficult, particularly if things are not labeled or if it's hidden away in the code. I would say the same thing is somewhat true in a long set of program code as well. You could do things obscure ways or more clear ways. Yes, Alexander. Oh yes, well there's a reason for that, and I'm sorry. I ignored my suggestions. Yeah, I should have been more careful than that. Folks, I made a boo-boo in terms of the rates. In terms of the assumptions for the rates, here since we had a fertility rate rather than a birth rate, this fertility rate only applies for women, and therefore it's going to lead to a net decrease in the population of the model. So let's make the fertility rate in the experiment 0.04, because then it's only half the population right now that's giving birth, the women, and the overall population would have been decreasing over time because the rate of births would be less than the rate of deaths. So Alexander, I'm grateful for you pointing that out. Someone over here, was it Ron? Did you have a question or?
Oh, yeah, no, actually I haven't.
TA? Okay, ladies and gentlemen, let's run this model. Okay, now I want you to note what's going on here. This is a point of some interest. Ladies and gentlemen, you'll notice what's happening. So let's run this again. Here we have our initial population. Note the difference from immigration. Here we have an initial population, and now we're going to be adding in people. Note the initial population is much of it is being lost, but a few families grow up, a few clans, and that population, that original population, many of the family lines have been lost now, but we're having certain families continue, persist, and even interlink some visually. So, the bulk of the people here have left no living descendants, it seems. Instead, the descendants are clustered in certain families. There's sort of there's been a loss of certain families, and other families have continued on. And you see some similar effects in sort of genetic drift type models and models of sort of family lineage. So certain families here have persisted and maintained. So here we have these family groupings. There's death going on, but it's death associated with these family clusters. Okay? So I'd like you, ladies and gentlemen, while you're running this, I'd like you to pause the model. Could you pause the model here? Use this pause up here. And I'd like to check out one thing before we break here. So ladies and gentlemen, if you pause it, and if you go dive down into the model, you'll find that you can browse people here. But I want you to note something here, that a lot of the people here are listed with a mother of root population -1. That means they have a mother, they were assigned a mother, but their mother is not currently in the population. The mother has passed away. The information on the mother is still being kept around, but she's no longer in the population. This population is currently of size 806, so I'm going to go down and look at some of the later people in the population, say person 805. This person was begat by this mother at population, who's currently at population member 223. And if we look, this person is a female Maori within the population, so it's number 805, and her mother, that is a female, and her mother is population member 223, which is a female Maori, who is descended from population member 195, who is female Maori, whose mother was there, but has now passed away. Okay? So you notice that any logic gives names to the people in the population according to their position in the population. And if the person is gone from the population, we still may maintain information about them, but they're given this population member -1 indication. That means they're no longer in the active population. Now, we could still go query information about them, but they're not currently members of the population. And this is important when you're computing statistics, if you're trying to understand the current structure of the population. Moreover, ladies and gentlemen, you have to understand a given person's ID in the population will be changing over time. So just when we refer to population member 195 up here, that's not going to be the same over the entire time of the model. It's kind of like your number in line. You're waiting in line. You say, "Oh, I'm the third in line," and later you become the second in line. But you're no longer the third in line. You're the second in line now. And so it is. Population member 195. Their identity will be changing over time. So don't use those identities. Population number, the person in the population to indicate their identity. If you want to connote identity, we can do it by adding in an additional parameter that's called their ID and give them a permanent ID, which won't be changing. And that's easy to do. And if people wanted to do it, we could. Furthermore, ladies and gentlemen, if we wanted to compute age, we could impose a continuous aging on this model by giving each person a birth time. You give them a birth time, and then they could calculate at any given point, they could calculate their age as the current time minus the birth time. Very easy to do, and it's a continuous aging. You don't have to divide into age categories. No needing to force fit them into 5-year age categories or 10-year age categories. You can just associate them with continuous aging. Is there a strong interest on anybody's part? It would take about 5 minutes to show either of those types of things. If there's a strong interest on the part of anyone, I'm willing to do that. I'm willing to give people permanent IDs and to give them show them a continuous age. But otherwise, my preference would be to refer you to some videos where I do that. Anyone interested?
Yeah.
Do you want to see it?
No, I was going to say just refer to the video.
Refer to the videos? Okay. Glad to do that. Okay. Okay. You want to see age? How many people want to see age? Okay. You want to see age? Okay. We'll do age here. And honestly, if we're going to do age, we'll just do the other one too. They're really quick. No, because the changes required for one are pretty much the same changes required for the other. So if you're going to do it for one, this is an economy of scale. Okay, ladies and gentlemen, let's do it. Ready? Okay. So we're going to go, and we're going to go up. Well, first we're going to go to person here, and we're going to add 2 parameters to that person. One, we're going to add in a parameter for their birth time. And second of all, we're going to add in a parameter for their ID. Birth time is going to be a double. ID is going to be an int. It's going to be an integer that's never going to be reused. It's like your Social Security number, or your social insurance number, or the equivalent in Australia and New Zealand. Sort of a unique ID that's going to follow you from then on. People comfortable with that? We just added birth time, which is a double, int, and ID, which is an int. Oh, people okay? People okay with that? Okay, ladies and gentlemen. Next, this is a nugget. This is nuggetable. Boy, is it. Okay, up in main, we're going to add in a variable. This variable is going to be called next ID. And we're going to make it an int, and it's going to hold the value 0. Okay? This is going to be the next ID we give out. It's kind of like the ticker tape system. Maybe you have it in departments of motor vehicles, or maybe you have it in certain government service departments. You go in, you grab an ID. Maybe you have it in laboratories for blood tests and so on. You go in and grab the ID, and you wait your place in line. This is going to be the ID we're going to give out, the next ID. Okay? Ladies and gentlemen, and we're going to have a sort of a ticker sort of system. Okay, ladies and gentlemen, we're most of the way done. Most of the way, not all, but halfway. Okay? Just a little bit more here. Okay, ladies and gentlemen, go to the population. This is where we specify people's characteristics. For the birth time of somebody, we want the initial population to have an age distribution, some age distribution. And without in any way suggesting that it's realistic, I'm going to associate people with a uniform distribution of age between 0 and age 85. Okay? And so their birth time, we're starting at time 0 here, without privileging that. We could start at a different time. Given that we're starting at time 0, this is going to be uniformly drawn between minus 80 and 0. They could be as old as 80. If they were born 80 years ago, they'd now be 80 years old at time 0. Or they could be as young as 0. Okay? That's their birth time. Some of them were born 80 years ago. Some were born just now. Okay? And then the ID, I'm going to give next ID plus plus. That means use the current value of next ID and then increment it while you're at it. Make it one bigger than its current value. This is our ticker tape system. Okay? People okay with that? People okay? Okay, ladies and gentlemen. Ladies and gentlemen. We're just about done here. We've got to do one more thing. One more thing that is incumbent upon us. It's this. When we add the person to the population, why is it complaining about this? What do we have to specify now? We have more parameters than the people. We have to specify a value for each of the parameters before, which were sex, ethnicity, and the mother. Now we have to specify values for which other parameters? Birth time and their ID, okay? So what is the birth time going to be for this current person? It's going to be the current time, as indicated by calling time. Time. What is the ID going to be? It is going to be the next ID, this dot main dot next ID plus plus. Oh, that gives me a bit of the willies, but it's the way we'll do it for now. So let me go put this up on the big screen. Okay. So let's go put it up there, and here we go. I like to be responsive to student requests, and I'm trying to oblige now. Oh, this is most uncomfortable. Okay, that isn't what you wanted to see on the big screen. Okay, there we go. Here it is. It's coming to you. There we go. Okay. Why do we have all these things after add population? Those are the parameters of the person we're creating. This is the baby's characteristics. Their sex is drawn randomly from the set of all sexes. Their ethnicity is the same as the mom's ethnicity. Their mother is the mom. The birth time is the current time. Their ID is whatever's the next ID within main, and then we make that one bigger just for the next person. It will be the next value to pull out. That is how we implement it. Are people okay with that? Yes. Push. It's a variable. This is a reference to this new person who was returned from add population. So a person was created by this and returns a reference to them. It's sort of a reference for a reference to this new baby. It's sort of the name of the new baby, and so it lets you request things of the baby or set their location.
It's a property of the transition.
No, it's what we call a local variable. It's a variable that we're using it for convenience right now to name them, so we can do some things with them, and then it's no longer something we have to worry about. Is that okay?
Type of person?
It's just referring to a person that already exists, the person that was created by add population. It's referring to that person.
So you can think of it, sometimes they have, like, so this main add population adds a person to the population, right? But it'll also return the person that is added in case you want to do something, but you don't have to do anything with that person. So once this function, once this transition is finished, and that person that you added, their name or their identifying qualifications, you don't need anymore, but the function still added the person to the population. So under some circumstances, you might want to add a person to the population, and then that new person that you just added, you might want to do something to them, like set their X location, set their Y location, set their mother, set that, whatever. And then when you're done that method, the identification for that person you don't have anymore, but they're still in the method.
Yeah. For example, you might want to record the fact that they were born, who their mother was, recorded to a database. This person was born to that person. So you give them a nice little name, baby, and you say, baby was born to so-and-so, and put that out in a database, or put it out in a file recording the results of the model. Does that make sense? Okay, ladies and gentlemen, let's run this thing, and now we'll see each person in the population having an ID and a birth time, but visually we can't really see much difference, but every person has a unique ID here, unique ID 11, 13, etc. And so we have a unique way of referring them. If we put them in a database, they'd have a unique ID. More than that, ladies and gentlemen, they're aging. We couldn't really see it, but if you went up here to their characteristics and you wanted it to have get age, you could figure out their current age, okay? And you could set their scale to be based on their current age. You could take, for example, the log of their, the current time minus the birth time plus 1, and that would be their current age. Or you could create a function that would be called get age. It would make them a little bit bigger over time. Okay, so maybe we'll close with this. I think I'll close with this. But these people are aging. If you want to see how I would capture aging, I would add in how I would actually get their age. I'd add in a function called get age. I add it here from general, and I add this function. It returns a value that's a double, and I'd return from it the current time minus their birth time. Okay? This get age function. So I added get age. I had it return a double, and it returns the current time minus their birth time. That will give their age. Okay? Current time minus the birth time. And then I would set their characteristics visually according to get age. So I could set the scale according to the log of get age plus 1. And similarly for Y and similarly for Z. Okay? So now we have a population which over time is aging in a continuous fashion. There we go. Do folks see that? What do we see?
People growing and dying and being born.
See that? Okay, let me show how I did that. Yeah. Let me show how I did that. I had get age here. Get age, I added a function, and this is, it returns a value, and this is the value that it returns. It's a double. Returns a value that's a double, and this is the value it returns. It's the current age, current time minus the birth time. If they were born at time 3 and it's now time 4, they're 1 year old. If they were born at time 2 and it's now time 4, they're 2 years old. If they were born at time 0 and it's time 4 now, they're 4 years old. Okay? This is get age. It returns a value, and it just returns the current time minus their birth time. Does that make sense?
How did you then get it?
Then I went up here, and I went and I set the scale to be log of get age plus 1. Log of get age plus 1, log of get age plus 1. Okay? Now really this should be done in a function of its own that says get current scale, get scale. It calls get age, but it just computes this, but I just put it here for simplicity.
So that means those 3 means that growing in all
Oh yeah, and maybe I shouldn't have it grow in Z. You know, it doesn't need to grow in Z. It could
height with
just height and width. So it's growing over time. As it's aging, it's growing. And why is it aging? Because time is marching on. The current time minus the birth time is getting larger and larger as current time goes on. So this is what we see. So here's our population. Okay? Yes?
So do you want to add in similar codes to your immigrant population to capture
Yeah.
time and ID?
Yeah. Yeah, we could do that.
Do you do the same exact code, or do you have to use a uniform distribution?
Well, okay, I'd make their birth be some draw from a distribution for immigrants according to when they were born. But their ID, I'd assign them just that same ID plus thing.
Would you have to write it like this, that uniform would say, from this?
No, you'd say uniform, like from, it'd be the birth time would be the current time, the current time minus some uniform distribution, because they're coming in now, and so they're going to be born some time ago according to their current age. And so I could show it, but I think we'll break now. We're going to break for another 10 minutes, and then we'll reconvene for projects. But yeah, here, I'll do it for you if you'd like to see that. Okay? Here we go. Okay. So we're gonna have this immigration going on as well, and what I'm going to do here is I'm going to unignore this, and here they're going to come in with a random sex. They're going to have a randomly chosen ethnicity from their distribution. They're going to have no mother. They're going to have a birth time that's given by the current time minus uniform. So maybe they're uniformly distributed between 0 and 40 years old. Obviously, you could draw it from a custom distribution or whatever for how old immigrants are. But maybe they tend to be less than 40 years old. And then they're going to be this dot next ID plus. We're going to give them a unique ID. So that's what I do. We give them a unique ID, and we give them an age as given by a birth time that's given by this. They could have been born at the current time, in which case they'd be 0 age now. They're just born before coming here as a babe in arms, or they could be have been born 40 years ago, in which case they'd be 40. They would have been born 40 years ago. Time minus 40 would be when they were born, their birth time. Does that make sense? Yeah. So we could add them in.
Saying your immigrant population is going to be younger.
Yeah, it's going to be younger. Exactly. So this would have a different distribution. Does that make sense? So now we have immigrants coming in, and they have births and IDs that are permanent, and we have births coming in as well. Okay. So we have both processes, and we could superimpose them. So now we have births. Oh man, look at that. The immigrants are swamping it. Okay. Yes. Oh, that I just did? Yeah. Yeah. That's a good question. You could do what you could do is you could set their color, set their visual color when they come in. Would be one way to do it. Either that or make color a parameter of a person. And so you could make it a parameter and use that as their color. Yeah. As you could set their color an immigrant to be, green and a non-immigrant to be black or whatever. Does that make sense? So this is the code I use for immigration. Yeah. This is to allow. She was asking your name again. Tiffany. Tiffany was asking asking how you could capture similar information for aging for immigrants and unique IDs for immigrants. And I just said this is how I do it. And so when they come in, they have a birth time that's the current time minus some current age that they're at, and I'm assuming they're younger here. And then we assign them an ID, a unique ID, a time of arrival. Okay? Okay. So that's continuous aging. People age in this continuous fashion. We don't actually need to keep ticking up their age over time. Instead, their age is just whatever it is at the current time based on their birth, their birth time. Okay? Okay, any questions? We're in break mode. So
wait, so do the immigrants have a birth time?
The immigrants have a birth time, yeah. I'm giving them a birth time here. I just put up this code in answer to the question. I re-enabled immigration. They asked, so Tiffany asked how I could have immigrants captured for birth time and for age.
Oh, I see.
Or sorry, I mean.
Birth time variable.
So I am. I'm giving them a birth time. This is a birth time. Their birth time is the current time minus some number of years ago that they were born. So if they were born, if the current time is time 20, and they were born 10 years ago, then the birth time was 10. We're doing it backwards because they were born some amount of time ago. This is the current time. They could be as old as 40 years old, I'm saying, or they could be as young as 0. If they're 40 years old, they would have been born at the current time minus 40, because they're coming in right now. If they're 40 years old coming in right now, and if it's time 50, then they were born at time 10.
So we're calculating their birth time based on their age, and the other one the other way with
Indeed. It's exactly it. We're calculated their birth time based on their age because they're coming in midway through life. So if we want to figure out their birth time, we have to take that into account. And here we're assigning them an ID. It's a permanent ID that's used for them. Question in the back. Plays. So next ID is like a ticker system you use to poll thing. So you get the next number in line. No, this is actually, next ID has nothing to do with age. It's just a unique ID for somebody. So we want to assign them an ID like number 1, number 2, number 3, that will be unique and will never change. And my point was the number in the population, like population member 3, that's changing over time. We can't really persistently say, oh, they're population member 3, because who's population member 3 depends on the vagaries of who dies, who's born. And so we wanted a unique ID to refer to them, an ID that will never change, that we could put in a database and say, at this time person 5 did this, at other time person 5 did this other thing, this other time person 5 died, and we'd know it's a unique person. Oh yeah, it'll run the same way. It's just a way of giving them a unique name. Yeah. Yeah. Chris?
So we introduced the variable called birth time.
Yes.
When did we use that? Because it was a function?
Yeah, it's a function, yeah. Yeah. So there's two separate issues. That's a good question. So there's two separate issues here, I think, maybe being conflated. So we wanted a way to figure out the age of someone in the population, right? And, with health data, you often, if you request health data, say from administrative databases or other sources, there's two ways you can ask for it. You could say, I want people's age and an event noted, right? So let's suppose the event is diagnosis with diabetes. I could say, I want to know, their age when they were diagnosed with diabetes. Another way is you tell me their birth year, and you tell me the year they were diagnosed with diabetes. I can figure out what their age was then, right? And this is the equivalent of that. We're associating each person with a birth time.
Right. No, I get that. So that's what you're doing. Is you're doing it two different ways.
Not really. I'm actually doing it one way. It's just that doing it one way implies for immigrants that I've got to figure out that birth time. So the only way I'm doing it is I have birth time, and then I figure out their current age from their birth time by subtracting I'm subtracting their birth time from the current time.
I think there's a more fundamental construction.
Okay.
I think this is something when you're building the model, right?
Okay. Okay, so I don't know. They have a birth time, and then there's a parameter birth time.
And then there was a function at some point defined called get age.
Yeah, this is all just in the past half hour, right? This wasn't anything before that. Because people asked me, do you want me to do that? I said, do you want me to add age?
So then the function for get age was defined.
Just now.
Birth time we defined early on.
No, birth time we just defined at the same time. We just did this in the past half hour. At the very end, when I said, do you want me to have continuous aging? I said, okay, fine. I'll add birth time. And then I added get age. And get age basically figures out, based on when they were born, figures out how old they are now. Based on the current time minus their birth time is how old they are now.
Birth time.
Right?
Birth time is defined. I'm trying to figure out
right.
Where birth time receives its value.
Okay. Birth time receives its value from two places. Well, there's three places in the model where birth time is set. So, Chris, the most notable place is if you go to Maine and you go to population here, right? Birth time is set between minus 80 and 0. So they could be as old as 80 now, in which case they're born at time minus 80. This is the initial time. This is the initial population. We're starting at time 0. So if they were born at time minus 80, they're currently 80 years old. If they were born at time 0, they're currently 0 years old. So I had to set their birth time based on that consideration. Does that make sense? Okay. That's right. And can I just highlight something for you that maybe will get to your issue? I would say that this is exactly the same as saying 0, 80, so 0 minus this. Okay? Do you see what I mean? It's the current time minus them being uniformly distributed between 0 and 80. Does that make sense? Okay, now, because this is completely consistent with what we see going on elsewhere, because when someone comes in via immigration, this person, we're asking when was their birth time? Well, they're now between 0 and 40 years old, but they're coming in right now. So let's suppose it's currently...
That's not birth time, that's date of arrival.
No, that's birth time that's being set. Add population. Each of these is the parameters of the person.
Right.
The parameters are the sex of the person. So
that's the computer, that's the simulation time. The order.
This is the simulation time. Yeah.
The order.
Yep, this is the simulation time right now. So the first thing we pass, when we add a new person in the population, we have to specify its parameters. So the first parameter is sex. The second parameter is ethnicity. The third parameter is mother. The fourth parameter is their birth time, the time at which they were born. Yep.
That's not the time. That's the time they entered the model. That's the time they were added to the population.
No. No, it's the time that they were born. They weren't in the model at the time, but they're coming in now at this time, right now. They're coming in as an immigrant. How old they are now to figure out when they must have been born. Because this is someone coming in.
Right. You're just making it up. It's not an actual birth time.
Right.
I get it.
Yeah. So we're imagining someone.
You're just imagining when they could have been born.
Precisely.
Okay.
Precisely. Because they're coming.
To link it to the birth time function. Wait a minute, you're not.
No. So they're coming into the population right now at time. Yeah, and it's exactly the same thing as I have for the initial population. Remember, this is 0 minus uniform, 0 to 80? And there it was 0 minus, because that was the current time. It's the initial population. It was time 0, minus their age right now. And this is the current time minus their age right now. It's when they were born. Yeah? Okay, that's...
I couldn't get past.
Yeah, no, I understand why you're confused. So that allows us to deduce when they must have been born. So imagine someone showing up, well, you're in the States, so imagine someone showing up, coming over to Buffalo from Canada. They're immigrating. They're currently 40 years old. And we would then ask, okay, well, when were they born? It's 2014. They must have been born in 74. You see what I mean? And so you give them a time of birth there. Between 0 and 40. We're assuming they're a somewhat younger population. But, that could be drawn from a custom distribution you define for your immigration situation. You draw their age from that distribution. Does that make sense? Okay. That's helpful. I would say though, Chris, just to sort of complete the thought here, the one that's most obvious is this one. When you add a baby to the population, their birth time is now. It's the current simulation time. It's right now. Whereas an immigrant arriving now, you got to deal with the fact that okay, they're arriving now, but they're some age right now old. So maybe right now they're 40 years old. So they must have been born 40 years ago. Current time minus this. And, to sort of complete the analogy, this is kind of like saying time minus 0. They're currently 0 years old, and so they were born at the current time minus 0. Does that make sense? Okay. So it's all the same kind of same basic idea. It's just it just may seem a little bit different facets of it. Yeah, I should have been more careful. It's because I had already said, okay, we won't do this, and then I said, well, okay, I'll do it on my own. But I should have been more careful with this get age thing. This get age. Yeah, it's time minus birth time. So this is, how old are they right now? Well, if they were born in 1974 and it's currently 2014, they're 40 years old. The current time, 2014 minus their birth time, 1974, which is 40. Does that make sense? Yeah. Okay. Sure. Okay, just let me stop the recording here and